Hello everyone. As one of the subscribers, I actually got inspired by Black Pen Red Pen's video, and for today's video we're going to do the following. Find A and B that are integers. In fact, they're positive integers such that, wait a second, these two are actually identical. And in fact, it's something that Black Pen Red Pen has already done. And his video yet, I'll put the link below so that you can go to check out his video about this problem. So let's do some changes so that we'll do something that's more interesting. For the first question, we're going to find out what A and B are such that 0.AAA continuously with the square root is equal to 0.b all the way down. But this time, instead of doing it in the common base, we're going to do it in base 5. And again, if you don't know what base 5 means, go check out my previous videos. I have a full explanation about what different bases do. Alright, second problem. Let's change it a little bit as well. This time, I'm going to put base 9 on both sides. Well, of course, they're supposed to be in the same base. Otherwise, it's just too easy or maybe too hard to find, depends on the situation. But then, it's not that much interesting anymore because we have already seen the square root, right? This time, I'm going to put a 3 here. Meaning, instead of doing with the square root, cube root on one side and see what will. Alright, here we go. Let's do the first problem. Now, again, let's take a look the right hand side first to see what we'll get if we write it as fraction. So, from the right hand side, we have 0.b all the way, which means, again, each digit is representing 5 to some power. And since they're at the fractional part, and since we're in base 5, the first digit means b over 5, or b times b copies of 1/5. The second b right here means b divided by 5 squared. And then we have b divided by 5 to the third power, and so on and so forth. So let's take a look what we can do. Let's see if there's any common terms. Well, on the numerator, we see that there's a b for all the terms. And in the denominator, they all have a 5. So let's factor b over 5 and see what we can reduce. After we divide by b over 5, the first term becomes 1. The second term turns into 1 over 5. And then we got 1 over 5 squared. And let's list one more. We will get 1 over 5 cubed, so on and so forth. Notice that here, we actually get a geometric series. What does that mean? Well, since we get a geometric series, we can just use the formula to help us calculating the result here. So we get b over 5, which is this part, times this infinite sum, which starts from n equals 0 to infinity, where the ratio is 1 over 5. And using the formula we know about the geometric series, this part will turn into, well, let's see. The first term is 1, so we have 1 divided by 1 minus where the ratio is 1 over 5. And if we simplify this part, the green part there, we have the denominator 4 over 5, so we flip it, we get 5 over 4. And therefore, here we actually have b over 4. Nice. So let's write down our final result here. B over 4. Okay. What does that mean? It means that now if we're replacing b by any integer numbers, we'll get the following. If b equals 1, we get the right hand side, which is this part, be 1 over 4. And b equals 2 will give us 2 over 4, which is the same as 1/2. b equals 3 will give us 3 over 4. And lastly, b equals 4 will give us 4 over 4. And again, 4 over 4 can be written as just 1 if we simplify it. So let's see. If we do the same thing on the left-hand side, without the square root, we will also get something such as 1/4, 2/4, 3/4, or just a whole number 1. But if we look carefully, since we have a square root here, which of these options will actually work? In other words, which of these answers are square numbers, or can be reduced into a nice fraction? Well, we actually get these two only. So this implies that a can only be equal to 1 or 4. And if a is equal to 1, which is on the left hand side, then we get the term inside of the square roots be 1 over 4, and the square root of 1 over 4 is 1/2, meaning the right hand side, b has to be equal to 2. If a is equal to 4, again, 4 over 4 is just equal to 1, so the whole thing just turns out to be 1, which is equal to the right hand side, and in order to match 4 over 4 right hand side, b has also to be equal to 4. These two are the solutions for the first problem when we were doing in base 5. Nice. So let's jump into the second problem. All right, here is the second problem. And once again, since we see that the base is 9, we know that these expression can be written as, we can write this left-hand side be the cube root of this expression, which is a over 9 minus 1, which is equal to 8. And then the right-hand side is, of course, just b over 9 minus 1, which, if we simplify, we'll get b over 8. And again, so why can we immediately tell the denominator is equal to the base minus 1? Again, it is because of the geometric series that we found. And if we use the formula of adding the geometric ratios, we will notice that somehow we will just turn the denominator into 1 less than the base that we start off. So let's simplify. So if we break up the cube roots to both numerator and the denominator, we will actually get the cube root of a over the cube root of not b but 8, which is actually equal to 2. So this number has to be less than or equal to 1. What should we do next? Next, we can just multiply both sides by 2 to get cube root of a has to be less than or equal to 2. In other words, the cube root of a has only 2 options, either 1 or 2. Why do we only need these 2 values? Well, let's consider this statement here. The left-hand side has to be equal to the right-hand side. In other words, this part right here, including the cube root, is actually a rational number. So It means that this fraction here, the cube root of a over 2, is also very good. So what does that mean? It means that now we're going to take the third power on both answers, telling us the possible a values will be 1 or 8. So let's see what. Okay, so from our last board, we found out that the only possible a solutions would be 1 or 8. So let's see what happens if we plug those numbers in, so that we will find out what are the possible b values. So if a equals 1 on the left hand side, we get, again, we can just rewrite it as a fraction so that it's easier to calculate. We have the following: the cube root of 1 over 2, which is equal to 1/2. On the right hand side, we actually already found out that the rational expression is b over 8, so that we get b equals 4. And that's one of the solutions. Now for the other solutions, the answer is 8. I'll leave it to you guys to check the answer. All right, that's it. So if you enjoy my video, don't forget to like. And if you have anything that inspire you or that you could think that you want to talk about, you can leave your comment below. And don't forget to check out my other videos from my channel. I'll see you next time.